Hello guys, welcome to the new video which is a continuation of my earlier video about heap data structure. This is a part 2 where I am going to implement the insert and DeleteMax functionality. Before going to the implementation, let's focus on how we can solve the insert problem in a heap data structure. So I'm going to insert an element using a method called swim or ShiftUp or BubbleUp. Given an array like this, so in the last video we have built up this heapified array. So it will satisfy the heapify property where parent element is greater than both the childs. I'm going to when you visualize this heap as a tree, it looks like this. So 9 is the parent, 8 and 6 are its child, 7 and 4 are child of 8 which are less than the parent. Similarly 5 and 2 are less than 6, 0 and 3 are less than 7 and 1 is less than 4. What I am going to do is I am going to insert a new element 10. Clearly you can see that 10 is the greatest among all. So what we will do is we will insert the element 10 at the end of the array. So when you see here we have 10 at the end of the array. Now the heap order is changed. We need to heapify the array. So what we need to do is since we inserted from the end of the array, we need to bubble up or shift up the inserted element in order to find its correct position. What we can do is we will find the parent of 10, which is 4 here, and check whether the parent is less than the inserted element. If so, we will exchange the parent with the inserted element 10. Similarly, we repeat the same process. So we find the parent of 10, which is 8, found out that 8 is less than 10, so we will exchange it. Similarly, we go up to the root, find that parent of 10 is 9 and it is less than 9, then we exchange 10 and 9. So thereby now our inserted element satisfies the heapify property. So when you look at it, 10 is greater than 9 and 6. Similarly, 9 is greater than 7 and 8. 6 is greater than 5 and 2. 7 is greater than 0 and 3. 8 is greater than 1 and 4. So now our array is heapified. Let's go on to the implementation of the insert functionality in the heap maximum priority queue data structure. Hello guys, welcome to the implementation of insert operation in heap data structure maximum priority queue. So what I am going to do is I am going to insert an element 10. So we need to have a public method to use the insert functionality in priority queue. So we start by adding a public method insert and which accepts the data. We call it as key here. Then we need to insert this key to the last element in the array. From my previous video, we see that our priority queue is initialized based upon the input array size. Right now our priority queue is almost full. So what we need to do is we need to resize the array. So I will check the size of the array, which is of length equal to priority queue. Then I use a inbuilt private method to resize the priority queue length twice that of the current length. We implement this function capacity. Okay, I will have a temporary array to hold the new capacity for I is equal to 0 to add element to the temp, and then we will mark priority queue to this temp element. Thereby we resized the array by twice. What we do is I will add the element to the last position in the priority queue, and I will use a method called swim to swim up or shift up from the last position. Let's write this method. So this position is the child element added, so we call this as element added, or we can call it as child, thereby easy to remember. What we need to do is like we need to check whether the child is greater than the lowest index 0. If so, we need to find the parent. The parent will be like half of the position from the child. So our parent position will be like child by 2. So in order to correctly find the parent, we will use this property child minus 1 by 2. Always the parent will be at half of the child's previous node. What we will do, like we need to check whether the parent is less than the child. If so, we will exchange the parent with the child, and then now the child becomes the parent. We will repeat this process until the loop breaks or this condition doesn't stand. Parent is not less than child. Let's run through this sample. So I have already made a method to accept insert element. Let's run through it. So when I run it, we have added a element 10 and the heap properties restored. So we need, in order to closely observe, on every exchange I will put a show of current elements in the array. As you see here, when we inserted 10, it will be inserted to the last position, and it will swim up to find its appropriate place in the array. First swim up to 4, exchange with 4, so the 4 becomes the last position and 10 becomes at the 4th position, and then the next pass it will exchange with 8, and in the final pass it will exchange with 9 to find its correct appropriate position. So this is the implementation of insert functionality in heap. The next one will be the implementation of delete functionality. As you might seen from my earlier video, we have done heap sorting. We use the exact same principle applying to delete the maximum element in the heap. It should be simple. We find the maximum element from the topmost element in the heap. We will return it. Okay. So in order to delete it, what we can do is like we can reuse the sort functionality. I will decrement the size of the array, exchange the first position with the last, and then sync from the first position. By applying this principle, we can able to delete the element from the maximum position. In order to encourage garbage collection, what I will do is like I will mark the last position to null. So while we inserting, once we run out of space, we have resized the array, right? So similarly, in case of deleting, we just need to reclaim the array space. What I will do is like I will check whether the size of the array is greater than 0, as well as array's length is 1/4 of current priority queue's length. So if it is like this, we will resize the array with priority queue dot length -1/2. So we will half the array. Once we reach the 1/4 space, we will half the array. Thereby I have implemented the delete maximum functionality. Let's run through this. We will delete the topmost element, which is by now 10, and we will show whether the heap property is maintained. So we deleted the maximum element and our heap property is maintained. When you can check. That's it with the implementation of insert and delete max functionality in PriorityQueue. This code is available in my GitHub link. As a final touch, I would like to introduce a class called PriorityQueue inside java.util package. Okay, we have a PriorityQueue data structure which was inbuilt in Java, which can store the elements in a heapified order. We can use this class to implement our max or min priority queue functionality. So I am going to implement a min priority queue. So what you can supply here is like, this is the constructor of priority queue. If you supply comparator.reverse order, it will become a maximum priority queue. Otherwise the default will be the minimum priority queue. What we can do is like, we can use the offer method, same as the queue data structure in the java.util class. We can use offer method to add elements to the array, to the priority queue structure. So I am going to add 10, I'm going to add 5 in the reverse order. I'm going to add 11. So we will print out the queue. Let's check how it is ordered. See here, I have inserted 10, 5, 11, and it is ordered in the minimum priority queue way. So 5 becomes the parent, 10 and 11 becomes his child. It satisfies the heapified property. So we can use this data structure in order to implement the heap in a minimum priority queue way. That's it I want to demo. One quick tip: if you want to find the kth maximum element or kth minimum element, you, before considering sorting the input array, just consider this priority queue way of arranging the element in a minimum heap order or maximum heap order. Thereby we can easily find the kth minimum element as well as kth maximum element. So try it out on your own. That's it with the video. Hope this video helps you in understanding the heap data structure and also the priority queue ordering with the heap. Thanks for watching this video, and subscribe to this channel in order for me to post some quality contents like this. Thank you.